Welcome back to the OpenUK Mini-Moo lessons. This is lesson 3 and it's called Steady Glove. You can start and stop this video at each step if you need more time to keep up with the lesson. Stephanie has an idea for a game that she wants to play with her friends. She wants to challenge her friends to a steady hand game. The game involves walking slowly and carefully to the other side of the room as if they were holding a delicate object, such as a glass full of water, without spilling a drop. But her mum doesn't like the idea of the carpet getting wet. Stephanie thinks it would be possible to play this game virtually using her Mini-Moo glove. In today's lesson, you will help Stephanie to design a program for the steady hand game. By doing this, you will learn about events, variables, including Boolean variables, loops, ifs, and nested ifs. You will also learn a little more about open source. You will need your assembled Mini-Moo glove, the MakeCode web coding editor, a large room to practice in, and a very steady hand. You might also find it useful to have a small object to carry in your glove, so you can imagine it's very delicate and fragile to the slightest of movement. Right, let's get going. Just like the previous programs, slot a play note block from the music palette into the onStart event handler and set the note length to 1/16. This is so that you know that your program is running, as the display of the microbit is hidden by the glove pocket. The steady hand game will start sensing movement when you turn your glove over, palm side up, and if you move your hand too much, an alarm will sound. To stop the alarm, you put your hand facing forward like a stop symbol, and it silences the alarm. So the glove has two modes. It is either monitoring your movements or it's not. For the game to work properly, the movement sensing needs to be turned on and off at the right time. And to do this, let's use a variable to decide if it's running or not. A variable is a named location in the computer's memory that varies or stores different values. It's just like the memory on your electronic calculator. Because this variable only needs two different values, we can use a special variable called a Boolean variable. It's named after George Boole, an English mathematician and logician from the 1800s. A Boolean variable can either be true or it can be false. From the variables palette, choose Make a Variable and give it the name Run. The game will start when you turn your glove over so that it is palm up, and you can sense this with the on-screen down event handler from the Input palette. Using an if statement from the Logic palette, join it up with the Run variable from the Variables palette. This if statement is really here to make sure that the on-screen down event is only sensed once at the start of the game. Finish it off by slotting in a Set Run To block from the Variables palette and the word True from the Logic palette, and follow it with a Play High C for 1/4 beat. The sound will be a cue to the player that the game has just started. Well, the on-screen down event handler is a bit more complex than your earlier programs. Let's just recap what it does. The first time the microbit senses that your hand moves palm up, it will change the run Boolean variable to true and play a beep to let you know the game started. If the microbit senses another screen up event while the game is playing, then the run Boolean variable is already true, so it won't beep again. Using a Boolean variable with an if statement like this is a common programming pattern we can use to make something happen exactly once. In a previous lesson, you used the onShake event handler to sense movement. However, the standard shake sensing of the microbit won't be sensitive enough for this game. So let's be adventurous and write our very own gesture sensing code. The forever block is a loop. It loops round and round forever, running any instructions that you put inside it. But we decided earlier that our movement sensing will only be needed when the run Boolean variable is set to true. So let's use an if statement to check the value of the run variable. Grab an if block from the Logic palette, and then grab the run variable from the Variables palette and join them together, finally dropping them inside the forever loop. Well, that's a good start, but it's not quite finished yet. We're now going to use something called a nested if statement. That sounds complex, but really it just means that one if is inside another if. Both of the conditions must be true for the code to do something. Grab another if block from the Logic palette and slot it inside the first, and you have made a nested if. Still not quite done though. We need a condition for the inner if statement. The condition we're going to check is if the acceleration x value is greater than 500. This basically means that if you tilt the glove sideways by a small amount, it will run the code inside the if statement. You can find the acceleration x inside the input palette, and the greater than sign is in the comparison section of the logic palette. Slot them all together and type in the number 500. Wait a minute. The x value will be at 0 when the microbit is flat. It will be positive when it tilts one way, and it will be negative when it tilts the other way. So, we want the alarm to sound whenever it tilts too far to the right or too far to the left. We can fix that simply by ignoring the minus sign on the number. There is a block inside the math palette called absolute value of. That will do that for you. Go and get that block now and wrap it round the acceleration x block, and it will make sure that your glove is sensitive to tilt in either direction. No cheating here. Finally, if the glove moves too much, we want it to continuously sound an alarm. Instead of using the play note, like we have done before, choose the ringtone block from the music palette and use a middle C. This will start the note playing and leave it playing, just like if you'd leant on a piano keyboard. So it makes a good alarm. Well done, your program is nearly finished. Your new gesture sensor program is written, and the alarm will sound if you tilt the glove too much. Now, it's going to be very annoying if you set off the alarm and have to fiddle around with the switch on the battery pack to turn the switch off. So let's make further use of that Boolean variable that we added earlier. Using the onLogoUp event handler from the input palette, we can sense when you make a stop gesture with your hand. Slot into this a setRun2 from the variables palette and join it with a false from the logic palette. Finally, because we don't want the alarm beeping forever, slot a rest 1/16 block from the music palette at the end of this event handler, and the alarm will be stopped. Let's just recap what is happening here. When you hold your hand up like a stop signal, it changes the run Boolean variable to false. This makes sure that our gesture sensing code in the forever loop stops sensing movement because it only does something when the run variable is true. It also means that if you moved your hand palm up again, the on-screen down would correctly sense the start of a new game. So really, the run Boolean variable is like a light switch that turns on and off and can be used to start and stop different pieces of code in your program. This is a really handy trick to learn, and we will use this again in future lessons to do some really clever things. Well, that is fantastic. Well done for joining all those code blocks together. Flash the code onto your microbit and try it out by trying to walk from one side of the room to the other, holding a small object without moving your hand. You might like to experiment by changing the number 500, as this will retune the sensitivity of your custom gesture sensor. If the number is smaller, the game will be harder to play. And if the number is bigger, it will be easier to play. The number should be somewhere in the range of 10 to 1000. Try lots of experiments with your friends and fine-tune the sensitivity. The secret to an exciting game is for it to be hard enough that it is challenging, but not impossible. Games designers fine-tune their game designs like this by testing with lots and lots of different people and finding a difficulty that is almost but not quite impossible. And it makes their games really exciting to play. What a super game. Stephanie will be very pleased with your creation. Perhaps you should think about open sourcing your game so that others can play and enhance it. Aha! There's that phrase again, open source. Let's think for a moment about open source. Who are the creators of open source? Well, Imogen Heap and her engineers at MeMoo created the Mini Moo glove that you're using. Engineers at Microsoft created the Make code editor that you use to write today's program with. And engineers at Lancaster University and ARM created the very low-level programs that makes all of the inputs and outputs and other features of the microbit work. These engineers are all creators, and all of their work has been open-sourced and published on the internet for others to use and learn from. But you are a creator too. You've just created some source code for a program. If you share this program with others and give them permission to use and change it, then you've just become an open-source developer too. Okay, so that's the end of today's lesson. Keep experimenting with the program that you wrote today and fine-tune the sensitivity to make the game as exciting as possible. Remember to try and find a setting that is almost but not quite impossible for the most exciting game. We'll see you again at the next lesson. Bye for now.